Ask my instructor 9.4.25. Use the integral test to determine the convergence or divergence of the series below. What I'd like to do is review what is the integral test. Suppose f is a continuous, positive, decreasing function for x bigger than or equal to 1, and let the sequence a sub k be defined by the function. Then, if we add up these a sub k's all the way out, indefinitely, then the resulting infinite series and the improper integral either both converge or both diverge. The integral test is used for an infinite series which has positive decreasing terms that can be defined by a continuous function. And just a quick idea of what's going on. The geometry of the integral test can be seen below. The area under f is bounded above and below by series whose terms are a sub k. Sending n to infinity, we can see that the improper integral and the infinite series either both converge or both diverge. In the case of convergence, the value of the integral is not, in general, equal to the value of the series. The integral test only tells you if the series converges or diverges, so it's just a thumbs up, thumbs down test. For our problem, we're going to define f by looking at the terms of our infinite series. And what kind of function is this f that we've just defined? Well, because the function is defined for x bigger than or equal to 1, the terms are positive. It is also continuous because it is the product of two continuous functions, a monomial and an exponential. Lastly, it is a decreasing function because the derivative is negative for x bigger than or equal to 1. So one thing I just want to point out, e to the negative 3x squared, what you want to tell yourself, what you want to remind yourself is that is a positive number. E to the negative 3x squared, positive number. The negative exponent just tells you it's a small number. So we're talking about small positive numbers. And that's why I can claim that f is positive. I've got x is positive, the exponential is positive, I have positive times positive, it's positive. And then with the derivative, the e to the negative 3x squared, as I said, that's positive, but then look at 1 minus 3x squared. If x is bigger than or equal to 1, then 1 minus 3x squared is certainly negative. All right, so let's move on. So the series will converge if and only if the integral converges. Well, can we find this integral? Can we determine if it converges? In fact, the integral test is only useful to us if we can integrate. So let's work on integrating the improper integral. Keep in mind that to integrate an improper integral, you have to use limits. So when you do an improper integral, you integrate from 1 to b, and then you just send b out to infinity. Now, to integrate, I'm going to first focus on the indefinite integral without considering the bounds, and then I'll come back here. So let's just look at the indefinite integral. For this indefinite integral, I would choose u equals negative 3x squared, and then du would be negative 6x dx, and x dx, I would trade x dx in for negative 1/6 du. And I'm ready to make my substitutions. Once I make my substitutions, then I'm ready to integrate. The antiderivative of e to the u is just e to the u. And so now I'm ready to substitute back, And my final answer for the antiderivative is negative 1/6 e to the negative 3x squared. Now um, I put that value back into my definite integral. And so this is what I'm dealing with. So I need to evaluate, and when I evaluate, this is what I get. Now I'm going to do a little rewriting. Double negative, I get a positive. And then also, as I said, this e to the negative 3 b squared, that just means 1 over. That just means you're talking about a very small number. So 1 over e to the 3b squared. And you can see here what I'm talking about. It's a positive number. That's very small, actually, because keep in mind, b is getting larger and larger and larger. So in fact, as b gets larger and larger and larger, 1 over e to the 3b squared is going to 0. And so my improper integral, now that I've done all that footwork, I'm ready to do the improper integral, and that means taking the limit as b goes to infinity. And the improper integral, I get 1/6 times 1 over e to the 3. Now, I don't particularly care what that value is. What I care about is that it's a finite number. A finite number means that my improper integral converges. And so by the integral test, since the improper integral converges, the infinite series converges as well. And so I conclude by the integral test that my series converges. Take care. Have a good day.